My name's Jake Whitcomb, and I'm joined today by Amir from Data Science. I'm from the products organization, and together we're going to give you really a top-to-bottom demonstration and explanation of what we've built in version 8 for data science. And I think there's a little bit, for everybody here. We're going to start off by talking kind of from the ground up why these components are accelerating the development of AI applications. And then we're also going to talk about how that works, right? We're actually going to give you an end-to-end demo in a Jupyter notebook from data to training a machine learning model with the machine learning feature generation and serving predictions and deploying that model to production. So you're going to see a very technical piece at the end, and you're going to see a little bit of high level at the beginning. And going back to kind of the architecture slide, what tools do data scientists use? Well, they use, as we know, Jupyter Lab for writing Python. They use Visual Studio for debugging their code, for writing tests, for deploying that code. And so at this top layer where I have in red, these are the interfaces that data scientists use to operate and configure the underlying machine learning frameworks. Additionally, we have the application canvas. So if you've been out to the booths, you've seen the user interface to the platform in V8, the C3 AI application platform. And so let me talk a little bit about the qualities of this tooling first, before we talk about what they do specifically. First, these tools are interoperable. So if you're using the no-code Canvas tool as a data scientist for doing, let's say, loading data, kicking off an AutoML workload with a visual tool, that's all converted to the same code that a data scientist can then use on the code side of the toolkit in C3 AI Studio, where you access both the code tools and the application canvas low-code tools. And this is critically important when you talk about accelerating the AI application development journey, where a team has maybe citizen data scientists or data scientists that prefer to do certain repeatable tasks in a workflow, kind of no-code UI, as well as data scientists collaborating in code, right? And then the machine learning frameworks and services under the hood that you're operating for these interfaces are running at scale in this auto-scaling cluster, right? The AI application platform that's running on top of your infrastructure at the bottom layer, right? So we're really scaling out these workloads while providing the tooling layer, the interface for data scientists that they know and love. And the qualities of these are, you configure these components, right? So machine learning pipelines, I configure these pipelines in a repeatable way. I can extend them, and I can operate them in production. So let me specifically talk about each of these. So configuring is just like I do with an AI application we've seen over the last couple days, where I might start with something that's 80% ready out of the box, and I tune and configure the last component of that so that I can bring it to production and train my models, set up machine learning features, and so forth. Extensibility is something unique to the C3 AI platform, in the sense that just like an AI application, the actual underlying base components are also extensible. So let's say you have a very specific model risk management process at your bank, and you need to set up very specific approval workflows where a certain user role, your model risk management user, can promote a model and approve it for production, right? That can be an extension to the base workflow. So we may provide 95% of the component out of the box, and that base component can be extended and then reused across your organization. This is critically important because the tools that you opt into and you use with your tools, with your organization, should adapt to your workflows and not necessarily vice versa. And then finally, you can operate all of these. And this is critical because everything you do in experimentation, you want to be able to easily bring into production and reproduce those operations, those experiments at scale in a production system. And these AI applications are really the end goal, right? The end goal is not just training the model, but it's actually building an AI-rich application. So take the AI reliability application that Lila demoed yesterday. We're looking at the model operations page here, and we have 6 different models that have been trained. 1 live model, and 5 other challengers. And each of these models are maybe live at any given point, or they could be all monitored and with production workflows to, let's say, promote or demote or retire models, roll back if needed, set up automated retraining. And this is just one particular asset, right? I'm looking at a lube oil component here, a lube oil subject we call in data science parlance. And there are 3,000 in this particular system. And this system is the average reliability deployment. So our systems grow quite large. And so you can see for one of these subjects, we have between 2 to 3 models on average. So you get to 7,000 models in production quite quickly. And that number can grow. We've seen as large as 1.2 million in a trial. And in this case, we're scaling up to nearly 500,000 predictions per day. And across all of our applications, we're nearing about 2 billion predictions per day. So to do this, you can imagine that it's more than, the data science process is more than training the model. It's making sure that you have the operational workflows in place to deploy those models for the specific assets they want to serve, right? And maybe you actually group those assets by component type or behavioral group or region. I might want to train a single model as a template for each particular asset. A lot of our reliability applications, for example, for each of the 3,000 subjects, might start with one template model and retrain for each particular asset. And now I'm operating 3,000 models based on one template. All of these are model operations capabilities provided out of the box with version 8. So double tapping on this, it's more than just the model. In fact, what we're finding is that, this is a paper from 2015, but this is still consistent today. The model is actually less than 5% of the overall code needed for an enterprise AI application, right? The rest, the 95%, is the amount of code needed to operate these at scale and to do at-scale experiments, right? And to set up retraining workflows as part of your application. And this is critically important because, and often underestimated, when teams are kind of stitching together their own machine learning components, because you may be able to get to one good experiment with that approach, but when you go to production, you may incur long delays or have to completely re-architect the system when you go for that second use case. So C3 is really focused on trivializing that 95%. So the data science teams have pure flexibility in that 5% and can focus primarily there, right? Because as we heard from Dr. Domingos this morning, you can take you can get a good solution quickly with an off-the-shelf component for that ML algorithm, but the best solution is always a one-off, right? So our teams have worked for years to refine these models that are provided out of the box as templates with each of our applications. And the tooling that they're building on top of is the C3 AI application platform that provides them the capabilities to do that, and we're going to show you how. So to build these models and get them into production, you actually go through 3 major phases, right? Data operations, ML development or ML experimentation, and then production operations, or what we were referring to this morning as model ops, right? Or ML ops in some terms. And so you first load the data, you analyze the data, maybe in a Jupyter notebook or some visual tool like Ex Machina, or then you start doing feature engineering, right? Finding the predictive signals in your data and writing expressions that can be reused to train your models, right? These machine learning features are transformations on your data to create the input data sets for your machine learning models. Then I may kick off some automated machine learning, AutoML, for model training, or try different template models that are provided out of the box with my AI application. And then I deploy those models. And model deployment, as I mentioned before, is more than just deploying a model behind a REST API endpoint. In fact, it's quite a bit more than that, right? You need to have, when a new data element, new piece of data enters the system, I need to know how to get my data to that model, right? And if I have 7,000 models in my application, I have to have all of those model routes configured with full lineage from the model back to the features, back to the cohort that I'm actually serving with those models for all of the champions and challengers, all the way back to the transform data and even the source data. That full lineage needs to be captured. So model deployment needs to capture this full lineage. It's not exposing a model as a containerized REST API endpoint. I want to stress that. And then operating and monitoring, setting up the operational workflows in your production application for doing things like if performance drifts on the model, or if data drifts, or if I need to promote a better performing challenger, that I can automate the promotion of those or automate the alerts so that somebody can come in and make that change. Now, the common challenges that we see when teams try to go through this process with stitching together disparate components or so forth. First, we have siloed databases. Well, we understand that different databases have different performance characteristics, and that's why we do the same. We have key value stores, we have file systems, we have in-memory, we have Postgres relational databases. We understand that different database types have different performance qualities. But if you're using data scientists to build data pipelines or hiring a huge team of data engineers to do this on the behalf of data scientists, it takes a tremendous amount of work to integrate new data sources. When those sources change, you have to refactor those pipelines, which may impact the downstream models. And so you really need an integrated system to handle this for you and spend as little time as possible with data science effort in the data ops space. And the same goes with siloed data machine learning tools, right? We understand that you need best-in-class frameworks, right? You go to a conference and see a great new technology for some deep learning technique to solve a time series problem, and you want to install that from the open source community. That's great. But provide a common layer and a common workflow to bring those to production. Otherwise, you'll end up with disparate training elements trained on different data sets, and it'll be very hard to productionize the data. And also the security layer is hard to maintain that way. So these are common barriers. If you get this far, oftentimes we talk with data scientists that are really stuck at actually that first step. Then you may deploy a model, but oftentimes we see teams are spending a lot of time refactoring these models, right? It's passing off to engineering to then integrate with the application. Even if I get that deployed as a REST API endpoint in a container somewhere, you still rely on application engineers to set up those production workflows, to understand how data get to those models, right? A REST API endpoint does not get me there. And then finally, I do all this work, and then I find out, because I've stitched together different components, my production data mismatch with my training data, and I end up with a very lengthy and costly rework cycle, right? And then I have to kind of debug the whole system. This is not where we want to be. This starts to look a little bit like the 5 stages of grief, I think. Maybe we've each been in different areas of this. So C3 is provided, and really we've spent the last 10 years building this, but specifically in version 8, I think the experience has become much easier, much more intuitive, and much faster to onboard new data scientists into an integrated workflow. From the left to the right, single data access layer for disparate data sources, right? So you have one way to access the data, one way to provide security and access controls. And then common tools and frameworks to plug in those best-in-breed machine learning libraries and frameworks and tools. And then one way to get to production with these models, right? If you've trained it with an external system or with a C3 pipeline, or you've imported some model, these all go to production in the same way, so you can set up champion challenger tests and retraining workflows and so forth. So this doesn't mean that you can't, because we've standardized this workflow, it doesn't mean we've standardized the tools for you. You get to choose those tools. And specifically, from left to right, we've provided a rich set of high-performance databases. You've heard about Delta Lake integration, about Snowflake integration, about HBase, Hadoop, Amazon, Vertex AI. All of them are available to integrate with your common data model, right? And so data scientists now have access to these data. They don't need to get shipped these data. Languages and libraries. So just as in V7, you can import your favorite libraries, and we'll operate them on the auto-scaling cluster, right? We have centralized runtime management. What does that mean? It means that you get to pick your language. You get to pick the version of Python that you're running. The libraries, where you're getting the libraries, right? You could even expose a custom internal repository. I know some folks have that use case in this room. Or use public open source repositories. And then finally, ML tools. So you have the flexibility. We're going to show you Jupyter Lab integrated into the application platform today. But you can also, as we've seen, integrate with Vertex AI notebooks, Azure ML, Amazon SageMaker, Intel One API. The list goes on. We have an integration with Groby optimization for mixed integer linear programming for a lot of the supply chain optimization problems. So we're solving an immense set of problems with a common lifecycle across natural language processing, machine vision, forecasting, simulation, optimization. The list goes on, right? These are all running in production. And so what tools do we expose in version 8 to get there? These are the core components. Of course, all of the models in that architecture slide up front are available to the data scientist to extend from. So I could go and build based on lots of different capabilities, but these are kind of the main components that you'll see. You have, again, Visual Studio, Jupyter Lab, and Application Canvas as your sort of end-to-end interface for operating these components. And then under the hood, I'm going to walk you through each of these, and specifically datasets is the new capability for in-memory analytics and feature engineering in version 8. Runtimes and ML pipelines. Runtimes is the way I define as metadata a list of libraries and the repositories and the language that I want to use. And I can have multiple runtimes in C3. So this is actually a key distinguishing factor. Many tools that you may see in industry have kind of one runtime, maybe a special variant of Spark. And we have seen that oftentimes an application needs, even within one application, may need high performance GPUs, an NVIDIA V100, an A100 to do computer vision training, and then maybe a T4 for inferencing, and then CPUs or in-memory Ray cluster for doing ad hoc analytics. So you need the control over hardware and libraries as part of runtimes, and you need to have multiple of these oftentimes. And then finally, feature store. So if you're familiar with metrics in version 7, right? Metrics were stored as metadata. These are the transformations on your data that are reusable and provide the input to your machine learning models, right? Feature store allows you to easily define those metrics using pandas, and then also materialize these metrics if you want to get high performance characteristics like low latency serving. So kind of packaging all of those capabilities in an easier to use feature store. And model deployment and monitoring is the way to operate these models in production, monitor the performance over time, set up A/B tests in Champion Challenger and so forth. Machine learning pipelines is an extension, really a rebuilding from the ground up of our V7 ML pipelines. The main functional difference here is that we've introduced the full directed acyclic graph capability, which means that I can have multiple inputs to my pipeline. Let's say I have imagery data coming in. We're going to use today a use case, predictive maintenance of wind turbines. So maybe I have maintenance notes that are in a PDF somewhere, as well as telemetry data for the main bearing and the rotational velocity of my turbine. I can feed both of those into the same algorithm, maybe do natural language processing in an OCR on one set of the data, the unstructured data coming in, as well as PCA and other sort of normalization. Merge those two pipes together, operate these steps in parallel, and ultimately this entire DAG becomes a single pipeline that I can version. I can seed this as part of my application. And our applications come out of the box today with these as templates, right? So that you can get going. We provide sort of the 90% solution, then you can configure your features and train on day one. So built in also in version 8 is AutoML. So some of our feedback in version 7 was, and we think of AutoML oftentimes as automated, trying lots of different algorithms in an experimentation environment. But we also see use cases where I have an operational flow to retrain models in production, but I want to actually have AutoML as part of that. So we're making AutoML, wrapping it as within ML pipelines. Interpretability and performance monitoring is built out of the box, just like in version 7. So you can keep track of the performances over time, as well as the performance characteristics and the interpretability results. Excitingly, in version 8, we have the ability to define custom steps in a pipe without leaving Jupyter, right? And in version 7, and maybe you actually had to switch to a code editor on IDE and then learn as a data scientist how to provision that code, right? And this was still very powerful. You could create custom code and then have that as a reusable pipeline once you deployed that to your environment. But some of the feedback we heard was, as a data scientist, I'd like to do this all within Jupyter. So I define my class, as this is a custom principal component analysis step. And then I can also use much easier to configure out-of-the-box pipes by converting the native library, here a scikit-learn random forest classifier, directly to a step and running the whole pipeline. I can even expose hyperparameters and these are stateful objects that can be run at scale. And then finally, model deployment and monitoring, as I talked about before, with just a couple API calls, we allow you to not only deploy my model to run at scale behind a REST API endpoint, but create the model routes to different cohorts, different groups of ML subjects. So I may have 2 behavioral groups, or in this case, 2 types of assets that each are served by different types of models, right? I might find that one model architecture serves this type of asset better, asset type A, and another type of model serves B better, right? And or I might have one general model that is a champion model for my entire population and do challenger models for other subgroups. So this allows, by having these model routes set up, allows us to automate the prediction workflows and also make it very easy to promote and demote models in a production system.